Hey kiddos, what's up? Today we're going to continue learning about some more factoring. So just a quick review of what we covered last time. So notice, all of these have a lead coefficient of 1, so it should be pretty straightforward. So first thing we need to do is figure out two values that will multiply to -10 but add up to 9. So let's see. 10 times -1 is -10. And 10 plus a -1 is +9. So that checks out. So if you wanted to check yourself and use your box method here, x squared, -10, we should be getting what we discovered, which was x plus 10, x minus 1. So this would be 10x. This would be -1x. And you always just want to make sure that these middle terms add up to our +9x, which it does. So the answer here is x plus 10 times x minus 1. Why does it look like 11? It's supposed to be 1. All right. Next example. Same concept. Don't let the letters trick you, okay? X, y, same difference, okay, in this case. So we got y squared minus 2y minus 35. So I need two values that will multiply to -35 and add up to a -2. So I need it to add up to a -2. Let's see, 7 and 5. I need the answer when I add it to be -2. So I think the 7 is going to have to be the negative. So let's see. -7 times +5 is -35. And -7 plus 5 equals, yep, -2. So those are two values. Again, you can always check yourself by, using the box here. So it'd be y squared, -35. We have x minus 7 and x plus 5 is what we discovered. Those are two values that we got, okay? And this would be a -7x. This would be +5x. Remember, what we're essentially looking for is we want these middle terms to combine to what this middle term is. And I shouldn't have put x's. I need to pay attention to my letters because they're y's, not x's. It makes a difference. So used to always doing x that threw a little curveball at myself with the y's. So y minus 7 times y plus 5 is going to be our final answer for this problem. All right, next one. N squared minus 8n plus 15. Same concept. We need two numbers that are going to multiply to 15 and then add up to a -8. So straight from the get-go, if I know how to add up to a negative value, but I'm multiplying to a positive value, then that means my two numbers are going to have to be negative. And I'm thinking -5 times -3 is +15. -5 plus -3, check, is going to be -8. So you can always check yourself back into the box if you need to. And obviously, pay attention to your letters or your variables, the n. Okay, so n squared 15. We're saying our answer is going to be n minus 5 and n minus 3. So we would have -3n here, -5n here. You want to check to make sure that that actually would add up to a -8n, and it looks like it does. So n minus 5 times n minus 3. And we're just going to omit safety, I am not going to actually test you guys on anything like this. So, moving forward. All right, so how to factor polynomial with 4 terms. Okay, so example 1, factor 3x cubed plus 6x squared plus 4x plus 8. So the first thing that you want to do, step 1, is you want to factor out a GCF if possible. Notice for this situation, there is none. Okay, so step 2 is make 2 groups of binomials that have common factors. Okay, so I'm going to take 3x cubed plus 6x squared. I'm going to group those together, okay, because they have things in common. And then I'm going to group 4x plus 8 because I know they have a number value in common. All right, so now that we've made our 2 groups that have common factors, we're now going to actually factor out the GCF for each one. So I'm going to break this down over here. 3x times x times x. 6 would be 3 times 2, x times x squared, right? Over here, it'd be 2 times 2, x. And then 8 would be 2 times 2 times 2. All right, so looking for what they have in common. So let's look at our first pair. And I can see that the GCF is going to be 3 and 2 x's. So I'm going to take out 3x squared, all right? Remember, what goes inside the parentheses is what's left over, so what I did not circle. So in the first term, x, second term, 2, and it is positive 2. Okay, remember I get the sign from looking at the original. All right, now let's factor out the other one. Let's see what they have in common. What's their GCF? I have 2 pairs of 2's, so that's 2 times 2, which is 4. So that's GCF is 4. And it's positive, so positive 4. And then what's left over is x and a plus 2. So what you should also notice is that the values inside the parentheses should be alike. Okay, so they should be the same, essentially. So step 4, factor out the common binomials. So we basically don't need to have both of them, we just need one. So what's on the outside here is going to be one of our binomials, 3x squared plus 4. And then our second binomial is going to be just one of our binomials there that we had already gotten, x plus 2. And that would be our answer. So just some helpful hints. Change all subtractions to add the opposite. Adding negatives is a lot easier. And then if the first term in a group is a negative number, factor the negative out completely so that you don't have to deal with that. Makes it a lot easier to deal with later. So, all right, let's practice this. So I'm going to group this. So I'm going to have y cubed plus y. I'm going to group it like this. And then I have a negative 5y squared plus 5. Now, you might be wondering, well, how did I get plus 5? Because it says minus 5. Notice what I went ahead and did already is I factored out the negative here, okay? I just took it out already so I didn't have to deal with it. So, now we are trying to break this down to see what the GCF is. So, y cubed is y times y times y. And then we get y. 5 is just going to be basically 5 times 1. So y squared, y, and then just a 5. All right, so GCF here is y. And then what's on the inside, I have y squared. Remember, when there is nothing left over, it is always understood to be a 1. Okay, so positive 1. And then in the next one, we already have the negative out, okay? We have a 5 in common, so negative 5 is what the GCF there is. We're going to take that out, and what was left over is y squared. Again, notice there's nothing else left over, so it is understood to be a positive 1. So remember, we should have these two values, okay, our two binomials should be the same, okay? So what we end up with is this is one of our binomials, what I did with the squiggly line, so that's y minus 5. And our second binomial is going to be the y squared plus 1. Only need to bring down one of those. All right, example 3. All right, again, we're going to factor it by grouping, and you want to make sure you put them in groups and binomials that they actually have something in common. So I'm going to group 4x cubed, the minus 6x squared. And I'm going to group then the 10x minus 15, because I know 10 and 15 have something in common. All right, so now we're just breaking this down, finding the GCF essentially. 2 times 2, x, 6, 2 times 3, x. Some of you may not need to do this step and actually write it out, because some of you guys can actually look at it and tell what they have in common. So if you do, I'm going to allow you to kind of skip this step. But if you don't just see it right off the bat, then take the time to write this. It's worth it to get the right answer. All right, so here we have 2's in common and actually 2 x's in common. So we get 2x squared. What's left over is 2x. In this case, it'll be a minus 3. Okay, keep that sign. And let's see for the second one, 10x. All right, 10, 5 times 2, and an x, 15, 5 times 3. See, they have 5's in common. So we get 5. And what's left over is 2x minus 3. Again, I just kept the symbol the same here. I didn't take it out this time. Just showing you both ways that you can actually, approach these problems. All right, so from here, hopefully what we have inside the parentheses is the same. The GCFs are going to essentially be one of our binomials. So we got 2x squared plus 5. And then our second binomial, we'll just bring down one of the ones from above. And that would be our answer. Word. All right, so how to factor a polynomial with a lead coefficient other than 1. So here's our next example. First thing is that you need to multiply the first and last terms together. So first terms, last terms need to be multiplied together. So 2 times negative 21, okay, that gives us negative 42. All right, now we want to think of factors that are going to multiply to the negative 42, but are going to add up to our middle term, which is a negative 1. So let's see. I think 6 and 7. One of them's got to be negative, and I need the answer to be added up to a negative 1. So I think I'm going to go with a negative 7. So 6 times negative 7 is negative 42, and 6 plus negative 7 is negative 1. So those are going to be our two values. So basically we have negative 7 and positive 6. So I'm going to rewrite this out to say 2x squared, and I'm going to use those two values we just found, negative 7x plus 6x, and minus 21. And kind of like we were just doing before, I'm going to put them in groups. So I'm going to have 2x squared minus 7x in one group. And my other group is going to be 6x minus 21. Make sure they have something in common when we do this. All right. Now let's factor out the GCFs in each of these binomials. So let's see. That's 2x, x, 7, and an x. So notice they don't have any numbers in common, but they have an x in common. So we get x, and then what's left over is 2x minus 7. Remember, minus sign comes from the original. And now for the second binomial, 6 breaks down to 3 times 2, and there is an x. 21, 3 times 7, no variables. So they have the 3 in common. So take the 3 out, and what we have left over is 2x minus 7. Again, the minus sign is coming from the original. So hopefully, if we did this right, these two should be the same. So we know that our first binomial is going to be the one that's on the outside, our GCFs. And then the second binomial, we just bring down the one that we got that were in common. And that would be our answer. But like in math, there's always a different way to do this. So here is a different approach at it that if you like better, then roll with it. Kind of the same concept. We're actually going to kind of, in a sense, get rid of this 2, and we're still going to multiply it to the end. But I'm going to end up rewriting my problem to say x squared minus x, and instead of it being negative 21, it is going to be negative 42. Okay? So I'm rewriting the problem to where I'm taking away the lead coefficient of 2 and making the lead coefficient 1 again. All right? We're going to go back to that 2, though, so don't forget about it. We are going to get back to it, but let's just work this out then like normally we would. So we need numbers that will multiply to negative 42 and add up to a negative 1. We know that there are 6 and 7. 7 is going to be negative. 6 plus negative 7. All right, so that checks out. So you would end up with x minus 7 times x plus 6. Now, here's where you can't forget about that 2. What we're going to do is we're going to take that 2 and we're going to divide our number by that lead coefficient that we originally got rid of. Okay, so I'm going to divide both of these values by 2. Now you look to reduce. Well, 7 over 2, that's not going to reduce. So if it doesn't reduce, you just take what's in the denominator and you actually just move it in front of your variable. So it becomes 2x minus 7. Now, if you can reduce it, you should reduce it. So 6 divided by 2 does reduce to 3. So you end up with x plus 3. So notice we still ended up with the exact same answer. 2 different ways of doing it. Completely your choice as, deciding which way works best for you. All right, so let's look at another example, and I suppose I'm going to mix it up, so I'll do both, so that way if you liked one more than the other, you kind of can see both worlds. So example 5, I'm going to do it the first way. So first thing we need to do is multiply the first term and the last term, so 3 times negative 8. So 3 times negative 8, we get 24 negative, that is. So we need 2 values that are going to multiply to negative 24. And we'll add up to our middle term, which is a negative 10. All right. Well, you can just go through the list and try numbers. So, for example, 6 and 4 seem to come to mind. Negative, though. So only one value can be negative. So negative 6 times 4 is negative 24. But negative 6 plus 4 equals negative 2. Yeah, that's not going to work. Let's see. 24, 24. 12 and 2. 12 and 2. 12 times 2. And keep the 12 negative, 2 positive. That does give me negative 24. And negative 12 plus 2. Yes. We get our negative 10. Perfect. All right, so now you're going to basically rewrite our problem, but you're going to use the two values that we found. Minus 12x plus 2x, and then bring down that minus 8. All right. Now here, remember we group, okay, make sure they have something in common. So I'm going to group 3x squared minus 12x together, and I'm going to group the 2x minus 8 together. All right, looking for GCF. So we get 3x times x, 12, I'm going to put 3 times 4, and there's an x, 2x, and I'm going to put 2 times 4. All right, so let's see what our GCF is. We have a 3 in common and an x in common, so I'm going to take out a 3x. What's left over is x minus 4. Remember minus, because that's what it originally is here. All right, let's see what we get when we take it out in the other one. We have 2's in common, and that's it. So I'm going to take out a 2. And then what's left over is an x minus 4. Again, the minus comes from the original. So hopefully these are alike, which they are. So that tells me we're on the right track. 3x plus 2 will be our first binomial, and the second one is just going to be the x minus 4. All right, next. All right, let's try this the other way. They're still very similar. So 6 times negative 7, negative 42. So we're going to rewrite our problem. Remember, we're essentially getting rid of that right now. So it becomes x squared plus x. And we said that's going to be minus 42. Okay, don't forget about it. That 6, that's what I'm talking about. Don't forget about that 6. We're going to come back to it. Okay, but we're kind of changing our problem right now to x squared plus x minus 42. So we need two numbers that are going to multiply to negative 42 and add up to 1 this time, positive 1. All right, so I know the numbers are going to be 6 and 7, but this time, let's see, I think I'm going to be making the 6 negative. So negative 6 times 7 is negative 42, and negative 6 plus 7 is positive 1, which is what we needed. So essentially, we would have x minus 6 times x plus 7. All right, not done though, because we got to remember about that 6. So we'd have to bring it on down here and divide. Now remember, if you can reduce, reduce. If not, we'll get to our little trick there. So 6 divided by 6 actually does reduce, and that's negative 6 divided by 6. So you end up with x minus 1. And then 7 divided by 6, yeah, that's not happening. Cannot reduce that. So we take that denominator, and we're just going to move it in front of our variable x. So you end up with 6x plus 7. So that would be our final answer. All right, and another one. All right, so next example is 6x squared plus 7x minus 20. First thing we need to do, multiply the first term and the last term, and that's going to be, negative 120. Negative 120, and we need it to add up to 7. So some of you may have to go through a list of factors. If I'm not mistaken, I believe 15 times 8 is 120, but that 120 is supposed to be negative. Haha, caught that. It's supposed to be negative. So one of these numbers got to be negative. I need the answer to add up to a positive 7. So I think we're going to make the 8 negative. So let's check ourselves. 15 times negative 8 is negative 120. 15 plus a negative 8 results in a positive 7. All right, so now we're going to rewrite. You're basically rewriting the middle term by using these two values, okay? And obviously don't forget the letter x with it. So we get 6x squared plus 15x minus 8x minus 20. Okay? We're going to group it. So I'm going to have 6x squared plus 15x in one group. And then the second group, I'm going to have the 8x minus 20. But we have a choice here. We can actually, if we want, factor out that negative already. And then make these a lot easier for us. Okay, so now let's find our GCFs. Let's see, 2 times 3 is 6, x squared, x. 15 can break down to 3 times 5, and there is an x. 8x can break down to 2 times 4, there's an x, and 20 will go 4 times 5. All right, let's see what we get. They have 3's in common and 1x, so the GCF there is 3x. What's left over is 2x plus 5. Okay, now for the second one, we get 4's in common, and that's it. So notice I already have a minus out, so I have that 4 there, so it's minus 4 times 2x plus 5. So that's what I have here, plus. That's why there's a plus there. Notice these are the same, which is what we always want. So our answer is 3x minus 4 times 2x plus 5. All right, and moving on. Example 8, 2x squared minus 5x minus 3. You knew it was coming. You knew I was going to set it. I know you were dreading it, but the time has arrived for you to attempt this on your own. You have 2 different ways of approaching this problem. Decide which way you like best, and we will, if you have questions, go over this in class at the beginning. All right, ciao.